Today, factoring today. So first day of factoring, we're going to spend, I don't know, 3, 4, 5, 7, 27? No, 3 or 4 days factoring? 2, 3, 4 days factoring? Yeah, you've done this. You did this in Algebra 1. So you spent like a month on it in Algebra 1. So we're going to do like 3 days, which would be about perfect. Maybe 4. Factoring is one of the things you have to be able to do in any math class beyond now, is you have to be able to factor. And you got to be pretty efficient at it as well. So today we're going to look at 3 forms of factoring. We're going to start out with GCF. Really hit hard, how do you find the GCF, greatest common factor? The second thing we'll talk about grouping. And we're going to do grouping using the box method. I don't know what your algebra teacher did, but more than likely, if you had Winters, you probably used the box method. If you had Zurich, you probably used a different method, but I'm not 100% sure. And then we're going to talk about a shortcut to factoring called the difference of squares. And we should be able to get through all 3 of them today. It's going to take a little while, but oh well, you get to listen to my soothing voice. All right, so when we factor, what do we mean by when factoring? Factoring is essentially, wow, that was weird. Factoring is essentially if we take a monomial and a binomial. So we're going to factor starting with greatest common factors. And when we think about what we're going to do, we're going to kind of do backwards what we were working on earlier in the year. So earlier in the year, we worked on taking this monomial 2x and multiplying it to the binomial x minus 3x minus 1. And we did that by using the distributive property, taking 2x times 3x and getting 6x squared, and then taking 2x times negative 1 and getting negative 2x. So we came up with this simplified version of it. When we're factoring, we're going to do the exact opposite of it. Okay, we're going to change it from a binomial, in this case, to a monomial and a binomial. So the first one we're going to look at, and the best way to do this is just kind of go after it. So 5x plus 10. So what we're looking for is what we call the greatest common factor. And we're looking for the greatest common factor for both the number and the variable. So when we're talking about factors, we're talking about 2 numbers that multiply together that result in that. So if I'm just looking at 5, the only factors for 5 are 1 and 5. 1 times 5 is 5. So those are the factors of 5. The factors of 10, well, 1 times 10 is 10, and 2 times 5 is 10. So those are all of my factors of 10. When we're talking about the greatest common factor, we're talking about the biggest one that's a factor of both of them, or all of them. So in this case, 5, number-wise, is our greatest common factor. So that means I'm going to take a 5 and I'm going to factor a 5 out. So I'm going to factor a 5 out of both of these terms. Now we also have to look at the variable. The first one has an x in it. The second one doesn't. So since the second one doesn't have any variables in it, they don't have any in common. So we can't really take out a variable in this case. We can only take out the 5. So then we're going to put a parenthesis. Now I look at it as 5x divided by 5. So your 5 divided by 5 is 1. So that just leaves you with x plus 10 divided by 5 is 2. End the parentheses. Now the nice thing about factoring, the nice thing about factoring is you can always check your work. 5 times x is 5x. 5 times 2 is 10. This matches what we started out with. That's got to be my solution in factored form. Okay. GCF is the first thing you always have to look for when you're factoring. So every single one that we factor from now on, and now until 2 weeks from now, when we do the assessment over this, or the rest of your lives, Okay, like maybe 2 of you will do this the rest of your lives. That might be a stretch. The rest of you will just do it for the next 2 weeks. Okay, until you graduate. Anyway, we always look for GCF first. Anytime you factor, doesn't matter how many terms it has. If it has 2, 3, 4, 727 terms, always look for the GCF. Number-wise, 3x squared plus 4x. 3, the only factors are 1 and 3. 4, the factors are 1 times 4 and 2 times itself. So the biggest one they have in common is 1. So in a sense of the imagination, we're not going to put anything out there as far as numbers go. There's going to be a 1. If you want to put a 1 out there, great, but you don't have to. This is also 3x squared, so that means it has 2 x's. This is 4x, so that means it has 1x. How many x's do they have in common? 1. They have 1 x in common. They both have 1. The other one has 2, but who cares? They both only have 1. So I'm going to factor an x out. So that means I'm going to take each of these terms and I'm going to divide it by x. Numbers divided by numbers. 3 divided by 1 is 3. X squared divided by x. I had 2. I'm taking 1 out. So I'm left with 3x. Plus, because there's a plus sign in there. 4 divided by 1 is 4. X divided by x is 1. That's your solution. 3 times x is 3x squared. X times 4 is 4x. That's where I started. That has to be my solution. Okay. You're done. A couple things when you're factoring out that you want to make sure always happens. When you factor out, you always want to make sure that if your leading term, if your first term is negative, factor out a negative. So I'm going to change this problem. I'm going to make this problem negative 20a to the 5th minus 24a to the 3rd. Anytime your first term is negative, you're always going to factor a negative out. Now we're going to look at the factors of 20. It's 1 times 20, 2 times 10, 4 times 5. Don't think there are any others. Factors for 24. 1 and 24, 2 and 12, 3 and 8, 4 and 6. Everybody understands where I'm getting those numbers, right? 1 times 24 is 24. 2 times 12 is 24. I'm just listing them all. Now I look for the biggest one that they have in common. Biggest one they have in common is 4. So that means I'm going to take a negative 4 out. So I'm going to divide this by negative 4. I'm going to divide this by negative 4. Negative 20a to the 5th has 5 a's. This has 3 a's. How many do they have in common? 3. So we're going to take out a to the 3rd. A to the 3rd, a to the 3rd. Okay. So negative 20 divided by negative 4 is 5. A to the 5th divided by a cubed. How many do I have left? 2. 5 minus 3 is 2. There's 2 left. Now we've got negative 24 divided by negative 4. That's positive 6. A to the 3rd divided by a to the 3rd is just 1. Just 1. There's no a's left. 3 and 3, they just go away. So there's your solution. And again, if you multiply it out, it works. This is your solution for my changed problem. Now, questions become, is this necessary that you list all of these? And the answer to that is, as long as you get the largest one, I don't care how you get it. You don't need to list them. If your number sense is really good, which by showing the data of Austin Public Schools, it's not. If your number sense is good, you can do this in your head. Even if your number sense isn't good, most of the time you should be able to do these in your head. Most of you can figure out the factors up to like 100. Okay, that might be a stretch, up to like 50. When you start asking things like, what's 12 times 10? And people look at you and go, huh? It's those TikToks that always kill me. What's 3 times 8 squared plus 41? Who cares? I'm a math teacher, I do. Okay, let's look at this one. 15x squared plus 5x. Go ahead. Factor that using GCF. And as you're doing that, anytime you're factoring, GCF first. Anytime you're factoring, GCF first. Anytime you're factoring, GCF first. If you don't hear anything else I say all year long, which will be the case for some of you, anytime you factor, GCF first. Talked about turning my room around today. Having you guys look outside.
How would you teach?
I don't teach now. What would be the difference? Oh, yeah, I do. I got this thing.
You could write on the windows.
Well, no, that doesn't work very well, and they get mad.
Can you move that?
This thing moves. So I could move this over there, and I could take the projector and spin it around, and we could face that way. Just for fun.
For one day.
For one day. It'd have to be sunny outside, so maybe tomorrow. It's supposed to be sunny. Wouldn't be much fun if it was gloomy. The birds would be distracting. There's no birds. It's winter. What's the number-wise? What's the GCF? 5. Letter-wise?
X.
Or variable-wise? Now, again, do I do that every time? Of course I don't. 15 divided by 3 is? 15 divided by 5 is? 3. X squared divided by x is? X plus. This one messes everybody up. 5x divided by 5x is? 1. And you have to put a 1 there. Otherwise it don't work. Okay. Realistically, when I do these, I take that 5x and I say 5 times what is 15? 3. X times what is x squared? X. 5x times what is 5x? 1. I don't list this all the time, but it's a good thing. It's a good habit to be in. That's mathematically why it's done like that. And again, GCF, GCF, GCF. Always do that first. Any questions with factoring using GCF? Taking out a common factor. You're going to have to continue to do it because now we're going to factor by grouping using a box method. Okay, so everything we've done so far had 2 terms. 2 terms always, not always, but a lot of times 2 terms you're going to look to take out a GCF, unless they're the difference of squares, which we're going to talk about next. Anytime you have 4 terms, and they're all different, you can't combine them. We're going to graph by grouping or using what we call the box method. So it's exactly what it says. So if we have 5x cubed minus 15x squared plus x minus 3, we are going to create science term of Punnett square. So we've got 4 terms. We're going to make 4 boxes, 2 rows, 2 columns. The first 2 boxes, or the first row is going to consist of the first 2 terms. So 5x cubed minus 15x squared. The second row is going to consist of the other 2. Of the last 2 terms. So now what we're going to do is we're going to look at this column right there. And we're going to put the GCF of that column right there. So what's the GCF of 5x cubed and x? X. So I'm looking at the GCF going that direction. The GCF of that going that direction is x. Then we're going to look at the GCF for this, excuse me, and that's going to go right there. Now remember what I just said. Anytime your first term is negative, and our first term in this case is negative 15x squared, we're going to take out a negative. So what's a common factor, greatest common factor for negative 15 and 3? 3, right? 5 doesn't go into 3.
Yeah.
5 times 3, yeah. And do they have a letter in common? No, so we've got the GCF. So there's my first factor. So my first factor of this is x minus 3. That's my first factor. Now we're going to go the other way. So we're going to go this way. And the GCF for those is going to go right there. So the GCF of 5x cubed and negative 15x squared. Number-wise, it's 5. How many x's do they have in common? 2. So that's going to be 5x squared. Now we're going to go down here. We're going to do the same thing. That GCF is going to go right there. What's the greatest common factor number-wise? What's the greatest common factor that they have? 1. Do they have any x's in common? No. So the second factor is 5x squared plus 1. That's your factored form. And now again, could we check it by foiling? Yeah, if you switch it around. So the question over there that I'm going with was what this meant. If you write it as 5x squared minus 1 times x minus 3, is this the same thing? Yes, 100%. Same thing. Depends on how your brain works and how your brain wants to do it. Okay? No matter to me. Again, yeah. Okay, that's not what I wanted to do. Where'd it go? Where'd everything go? Stop! Ah, there it is. Okay, so let's look at this one. 4 terms means we're going to factor by grouping. If you have brown eyes and blue eyes, what color combinations can you have? Genetics. Oops. Oh, we have encountered an issue when syncing. Is that up there? Oh, you guys can't see. That's too bad. So 2x cubed minus 12x squared. Negative 3x and 18. Looks right to me. So we're going to go that way. Common factor for 2 and 3. Nothing. So x squared or x? Just x? Oh, no, tell me. Just x? Okay, just x. And we're going to do this one. Our first term, which is negative 12x squared, is negative, so I'm going to pull out a negative. Common factor for 12 and 18. 6. Okay. That works for me. Now let's go this way. Common factor for 2x cubed and negative 12x squared. My first term is positive, so common factor for 2 and 12 is 2. X cubed and x squared. X squared. And then the last one, first term is negative, so we're going to pull out a negative. Common factor for 3 and 18. 3. Nice job saying it, everybody. 2x squared minus 3, x minus 6. Or x minus 6, 2x squared minus 3. Either way. And again, you could figure it out if it's correct or not. Yep. Any questions? So now here's my next question. See how well you've been listening. When you were doing this problem back here, what did I tell you that you should always do first? I said it like 17 times. Take out A. Anytime you're factoring, take out A. GCF first, right? Did I say anything about doing that in these? Did I make a mistake by not doing that? Yes. Okay. Always check, even though if you look at it, there's not one. Always make sure that in your mind you check. I probably checked in my mind and seen this didn't have a greatest common factor. But if that had a common factor, I'd have to take it out. Okay, so I erred in not really looking for that first. Okay, same thing with this. 2 and 3 don't have a common factor, so it's done. They don't have one. Okay, but yeah, I didn't ask. Okay, so we factored by grouping. Go ahead.
If there is a greatest common factor, we just divide it by all the numbers.
Correct. Yep. Then just take it out, just like we did before. And then factor that part again. There won't be anything like that today, I promise. Okay? So the last part is a shortcut. It's called differences of squares. Differences of squares are going to be two-term polynomials or binomials. Differences of squares means the first term and the second term are perfect squares, meaning you can take the square root of them and get a nice result. If I take the square root of x squared, the square root of x squared is just x. The square root of 9 is 3. Difference means to subtract. So difference of squares means you're subtracting two perfect squares. When you have that, there's a very specific rule that's going to apply, and we're going to talk about that rule in just a second. But first thing I want you to see is I want you to see some examples of things that are perfect squares and things that aren't. So x squared minus 9, they're both perfect squares. We talked about that one. 100b squared. The square root of 100 is 10. The square root of b squared is b. The square root of 36 is 6. They're being subtracted. It's a difference of squares. The square root of a squared, a. The square root of b squared, b. They're being subtracted. It's a difference of squares. If we look at the ones that are not examples, the square root of x squared is x. Do we know the square root of 8? Probably not. It's a decimal. 2 radical 2. It's not perfect. So since it's not perfect, that's not a difference of squares. The second one, 4a squared plus 49. We know the square root of 4 is 2. We know the square root of a squared is a. We know the square root of 49 is 7. But they're being added. So therefore, they're not a difference of squares anymore. Difference means they have to be subtracted. So this first one is because of the 8. The second one is because of that plus sign. It has to be a minus. The third one, we don't know the square root of x cubed. We don't know the square root of x. Okay. Do we know the square root of x to the 4th? Does anybody know what it is? X squared, yep. The square root of x to the 4th is just x squared. So we know the square root of that. What about the square root of x to the 12th? What's the square root of x to the 12th? X to the 6th, yeah. Just divide by 2. I think that's a later lesson, but we did it, didn't we? So if you have differences of squares, so if you have something like a squared minus b squared, here's the rule. The rule for this is that the factored form of this is a minus b times a plus b. And all this is a fast way to factor differences of squares. They have to be differences of squares. Otherwise, this doesn't work. A is equal to the square root of a squared. B is equal to the square root of b squared. That's how we get those. Okay. And this is the form that we will leave it in. So if we look at number 6, it's x squared minus 49. I always look minus first. I make sure it's subtracting first. And then I say, okay, I can probably do it. Square root of x squared is x minus square root of 49, 7. So it's x minus 7, x plus 7. If you put x plus 7 and then x minus 7, it's the same thing. Okay. Next one. 9x squared minus 1. It's subtracted. Okay, so I can at least try it. Square root of 9. 3. Square root of x squared. Square root of 1. 1. So it's 3x minus 1, 3x plus 1. That's the factored form of it. Next one, go ahead. 16x squared minus 25. I'm going to have you do 2 of them. So I want you to do both of those, 8 and 9.
Let me check. You're to 21:43. Oh crap! I know. Woo!
So 4x minus 5, 4x plus 5, and then x minus 3y, x plus 3y. Happy, happy, joy, joy. Any questions with factoring? Square root of 16 is 4, though. We can't break it down because it's not squared. Because we're not squared. Yeah, because it's a great question. Because that's not squared, we can't break it down any further.
But if it was squared, then would you break it down one more time?
Well, you got to watch because the 5 wasn't. But so if you had something like 4x squared minus 16, then you would do it again. Yeah. But that won't happen today. 4x minus 5, 4x plus 5. Any questions about factoring? At least this type. All right, your assignment is inside of Schoology. I don't know if I've got Schoology even open. I do. You can add polynomials. College algebra, algebra 2. And I even had it in there today. And I think I even had it published. Look at that. It's there. Factoring by GCF, grouping and differences of squares. All 12 questions. Nice. If you have any questions, please let me